Hi everyone, welcome to the Aula of the TU Delft. Welcome to the reveal presentation of Delft Hyperloop 2. I'd like to welcome friends and family here today, partners of our team, Hyperloop fans, people watching the live stream because we're live at this moment. And also, of course, I would like to welcome the team. My name is Timo Vlot, I am Chief Partnerships of the Delft Hyperloop team, and it's my honor today to be your host. And for us, it's a very special day today, because after a long year of work, we finally get to show to you what we've been working on. But it's actually been 9 months ago since we had our first day. And a teammate of ours, Jelle, he made the comparison with the first day of high school. And perhaps you still remember that day. Of course, you were selected to your school because of your capacities and your skills. But I personally was still a bit anxious because I didn't meet my classmates yet. Would they be nice? Would they be friendly? And of course, I would have to work with them for the rest of the year. And that's what it felt like for us as a team. And the first challenge was to learn all 36 names by heart. It's quite a challenge already. But already during that weekend, I came to know the team as a very driven and motivated team, and also quite friendly, quite nice. So that was a great bonus. And now we're standing here today to present what we've built this year, the Delft Hyperloop Pod, Atlas. Today we also have two guest speakers. One of them is going to talk about building a transportation system and a city from the ground up, and the other will speak about the role of digitization in the transportation industry. But first, I'd like to give the floor to Eduard Snijders, our team leader. And if you look at the calendar of Eduard for the past 2.5 years, it says Hyperloop, because he was also part of the previous and winning Delft Hyperloop team. So as our team leader, he brings a whole lot of experience to the table. He will tell you today about why we need the Hyperloop in our society in the future. And he will also show to you what we think that future should look like. So please give him a warm welcome, Eduard Snijders.
Thank you, Timo. Thank you all. So, transportation is often quite a hot topic of conversation because it affects us all. It shapes our day. If you have an accident on the A5 or you miss a train because it's delayed, then it can ruin your day. Or on the other hand, if roads are empty and you're able to catch a train earlier because it was delayed, it can make your day. I'm willing to bet that it's the most recurring conversation you'll have when you enter a room, whether it's your home or an appointment. How was your trip? Or the traffic was horrible. Or the bridge is open. So, not only this, but transportation also shapes the world around us. We pave empty spaces with concrete and make roads. We dig under the sea to connect islands and connect the mainland. And we fill the sky with airplanes, mostly for our fun, for vacation. In fact, the TU Delft recently released a statistic that said by the year 2100, the average amount people fly will increase by 9 times, and the average distance will double for tourism. Now that's amazing. I mean, I love traveling, and traveling is great, except for all the carbon emissions this will produce. The message, in fact, was that tourism in the aviation industry alone will actually make reaching the Paris Accord goals impossible. In order to reach these goals, not only will growth of tourism and in the aviation industry have to decline, but the actual industry will have to shrink in certain areas, meaning you'll have to fly less. So tourism will make reaching the Paris Accord goals impossible. Now, I don't have to tell you how serious this is. I don't have to show you a picture of a dying coral reef, a growing desert, or a skinny polar bear on an iceberg. If we don't act now and greenhouse gas levels stabilize at the levels they are today, then we are already committing the Earth to rise above temperatures above 2 degrees above industrial levels. So we have to act now. So what do we see? Most of all, we see a need for change in the aviation industry, in the plane industry. Despite the fact that we are emptying cities of dirty diesel cars, we seem to be completely overlooking the tons of kerosene that is being burnt right above cities. And a sustainable revolution is needed in this sector. Transportation, Hyperloop, a new transportation technology could be that revolution. Hyperloop travels in vacuum tubes and makes use of this vacuum, or the lack of air resistance, in order to travel extremely fast, 1,000 kilometers per hour. It's really a simple concept. You take away the current limiting factor of transportation, air resistance, and so you go faster and it costs you less energy. In fact, it costs you 3.5 times less energy than an airplane. But there's more to this than we first see at the surface. Because you're in a tube, you're actually removing yourself from external influences, such as air, storms, rain, or plants. You can't have a tree fall on your Hyperloop track. This means that you reduce the amount of varying factors you're designing for, and it means that your system becomes more flexible. That also means that you can build a system fit for purpose, specific to a region's needs. You can build long pods, you can build short pods, you can build simple, unpressurized pods for goods, or you can build complex pressurized pods for passengers. But this flexibility at the same time also means that integration between concepts and parties is essential. So we put our engineers to work, and we found out that per kilometer, a Hyperloop track will cost about 40 million euros on average. Now, making the assumption that Hyperloop will take about the same passengers as the aviation industry, so meaning that we'll take some passengers from trains and some from planes, we calculated that the ticket of a Hyperloop will actually be about the same as that of an airplane. I mean, that's amazing, right? It means that we can travel the same speed, well, actually a little bit faster. It'll cost you the same, it'll be more convenient, and we won't be destroying the world. So now, let me show you a Hyperloop network. Wow. So at Delft Hyperloop, we believe in a simple European network. A metro-like network with not many switches that connects European hubs. Few switches because that is more safe. Where tubes come above ground, aesthetics is extremely important to us, as you can see here. And we'll actually cover the tubes with solar panels so they can create energy that can be used by the Hyperloops inside. Where tubes go underground, because, for example, around cities, tubes will be underground, as obviously today cities are jam-packed. Tubes will be used not only for Hyperloops, but will be multifunctional. And will be also used to carry power, as well as data cables, and also for storage of rainwater and sewage underneath. But having a tube underground also has many benefits, as you don't have to deal with the structural problems of being outside. And so we arrive at our Hyperloop station. Your typical Hyperloop station will look something like a mix between your typical metro station and your typical airport. Metro is the best word, I think, to describe the passenger flow, the fact that stations will be underground, and the fact that travel times between hubs will be short. And airport will signifies the security aspect of your station and the fact that you'll be traveling internationally. I just want to take a moment to say, how cool was all this work? These are concepts that have actually been engineered specifically for Hyperloop and that could actually work in the real world. This station has been engineered for the dynamic passenger flows and for pods to depart every 1 to 3 minutes. This fast rates and constant departure will also take a load off security and check-in times. Our vision as a team is to have an impact on the future of Hyperloop, and we do this in multiple ways. Next to the work I just showed you, next year we'll be launching a massive online course, open for everybody. This year, we've also launched Hyperloop Connected, a website that brings together government, corporates, and students on everything that is Hyperloop. All these initiatives we have done in order to accelerate this really promising technology, because there's no other way of looking at it. In order to reach our Paris Accord goals, we have to start looking at drastic solutions. Thank you.
Thank you, Ed. And if you like the station render so much, and you would like to experience it in a more immersive way, then we have something for you. We made a virtual reality app in conjunction with NLR, the Netherlands Aerospace Center. And you were all given oh yes, I hear some plastic now. That's good to hear. It is not online yet, guys. You have to pay attention to our presentation first. I'm so sorry. But after the presentation, grab your phone and go to delfthyperloop.nl/VR. And then put your phone in landscape orientation. Unpack your phone holder, your cardboard. You can put your phone inside the holder, bring it to your eyes, and then you can have a look at the station in 360 degrees. Okay, so Edward was talking about the necessity of innovating in, for example, the Hyperloop. And he also showed us sort of the promised land in the footage. But we as a team are not the only ones that believe in this urgency and the promised land. Because we are backed by 86 partners, all sitting here, from the industry, providing us with financial means, materials, tools, expertise, software, and so much more. And without their willingness to help us and their generosity, we wouldn't be standing here today. So I'd like to thank all our partners today. Please give them a big round of applause. So I would like to share a story of how we met one of our partners. Often as a team we are invited to speak at events or showcase the pod from the previous team, because of course our pod is still a little bit of a secret. And last October, me and Edward were invited to go to Amsterdam, to the data disruption event there. And we met a few guys from Cognizant. They're an IT services and consultancy company. And we spoke at length about what we are doing as a team and also what they're doing in the transportation industry, among others, and what role digitization plays in this. It really clicked, and a few days later, we were invited to come and speak again, but now about a partnership. And as you can see from the slides, and also if you look closely to my shirt here, it worked out. We made a deal, and now they are the prime partner, so the main partner of our team, and they're among others helping us testing the software systems of our pod, which is crucial for such a short and intense run at the competition. So we've invited one of the gentlemen from Cognizant to come and speak to you today about the role of digitization in the future of transportation, and also elaborate a bit on our partnership. So I would like to invite Manoj Mathew, industry partner from Cognizant, to the stage. When I first met this guy, I was really inspired by his story, and I think he'll do the same to you. So please give it up for Manoj Mathew.
Thank you. Goedemiddag, everyone. Glad to be here. We met very fortuitously, two very compelling gentlemen, a few cups of coffee, and we think we had a relationship going. And we're pretty happy where we are, after so many years of watching them burn their fingers and staple the wrong foot to the floor. My name is Manoj Mathew. I'm part of Cognizant. We're probably a company most people have never heard of. We'll try and change that in a few minutes, but that doesn't really matter as to what we do. What matters is why we're here. It's because even though we started out as an IT company, many years ago, we've noticed that things changed way too suddenly for a lot of people in the past 2-3 years. And I'm sort of trying to put logic behind it, right? So it all goes back to a book that I read, and this shows you how old I am, right? It was probably a defining novel about Japan. Why? Because not too many people went to Japan in those days. So, if you didn't read Life magazine, you read Shogun to understand what it was. But one thing stuck, right? And there was this little line which said that a man has 3 hearts. There's the heart that you keep in your mouth, which you show to everybody. That's like Facebook. And then there's the heart that you have in your heart, which you show to your friends and your family. That's probably like your agenda, so people know what you're doing and when. And then there's the heart that you have internally, which you don't show to anybody else, and that's the one you have your own private conversations with. So when you read the book, you think it was a very Japanese thing, but it wasn't, because every culture has the same thing, right? It's got the inside and the outside, and I think most of us relate to this concept. Now, a lot of times when we design stuff or when we build stuff, we usually build it for the outside. And if you look at travel, the first hard question for travel is, how do I deal with congestion? How do I reduce my pain of going through security standing like this? That's all your first problems. Your second problems are, I've got a job, I've got a social role where, I have to travel with my son when he's on a football coaching trip. I've got to travel with my friends when we're on holiday. How do I balance all this, right? Most of us would have noticed that we take way more trips than our parents ever did. And that's probably a magnitude more than our grandparents ever did. But if you look into your heart and the innermost heart, and you try and understand why people travel, these are very personal. And the hypothesis here is that what's in your heart really wouldn't change over a lifetime. The reasons why people travel remain the same. When the first caveman got out and saw a man riding a horse, the desire that he felt to travel, whether it be to get from point A to point B or just have fun on top of a horse, it still remains the same, right? The reason I bring this up is total lateral segue. I'm sure a lot of you people might recognize this picture. It's the man who invented the digital camera, right? He said, here's a product, and it takes pictures without film. It almost made the company that he worked for go out of business because they didn't pay attention to it because they were making very good film, right? It was years before this happened, right? You have a digital camera, and it's not even in the picture because you know it's up there. You don't want to see the device. It's either an iPhone or it's Android. But what made the digital camera really useful to people and why the markets took off was because a few people, and Steve Jobs among one of them, really put to the aspirations of what's in your heart. That you can take pictures when you want. You can get a moment and you can capture it without preparation, without going through 2 focusing rings and all that kind of stuff. But you would think that's where it ended, but no, this is what really made digital photography and personal data sharing big, because I could take a whole lot of photographs, but if I had to invite everybody home to a wine party to show you my photographs of us on holiday, it doesn't quite work. This event is being live streamed, and there's a few people looking at it, right? And it's only possible because of a digital integration between the fact that we have this event here and that probably somebody sitting in Germany is watching this, or probably someone sitting in Brazil is watching this at the same time. So what we noticed, and what a lot of companies now notice, is the concept of integrating a digital experience, not just with the device, not just with the software and transports, but essentially designing devices which are expected to appeal to your inner heart. Now let's go back to travel. Let's go back to the airplanes that Edward doesn't like to talk about, and let's talk about everything else. This is a Pan Am ad from just after World War II, right? That's the time when your airline was your partner for exploring a foreign country. Most of you who would go back and refer to encyclopedias would find out that you can actually go in, book a ticket, book a hotel, book an entire trip through your airline, right? Sometime later, this happened, which is airlines were not really famous for being the best experience anymore. I mean, unless you are traveling business, which not many of us have the luxury to do. So an airline is associated with getting a cramp on your knees, going through 5 layers of plastic to eat some really unhealthy food, and then have it taken away from you before you could even enjoy it because you're landing now, right? In fact, in 2014, CNN actually did a review of best airport restaurants around the world. There's a whole economy in eating at airports, and some really fantastic restaurants in airports. Because I travel, I can tell you that, right? Nobody reviews airline food anymore. And airline food itself is a noun which doesn't mean good food, right? So at some point in time in our lives, because of technology, because of the urge to efficiency and all that, a lot of us lost the way into digital integration. And then there were all these remarkable new products like the iPod and Spotify and all that, or Uber or Amazon, which brought the experience back to you. What we really want to understand is why things need to be done in order to integrate how things need to be done. At a time when you could get everything you wanted out of a TV, it was important just to design a television. But when you want to really follow football, regardless of where you sit, you have to understand how to get connected to the football community, not just through the TV, but through the digital world around you. So here's another interesting story. We were doing research for a company about designing the next generation of automobile, and I won't go through this in much detail, but one of the people we interviewed in China, he was like a performer, he was like a singer. And we said, what's great about a car for you? What matters? And how do you use it? And he said, I like to sleep in my car. And before I get to my destination, the driver drops me off almost a kilometer from where I am. And then I like to walk, so I'm all ready for my next performance. This is not the kind of input which automotive manufacturers usually get when you start designing for demographics or specs, right? When you start looking at why should you build a good SUV, you would think horsepower and stuff and all that. And typically, when we get to interviewing people for research, that's the data they give us. I don't like noise. I want to use the truck for driving to work. But then when we start looking at the data around you, right, you start looking at the truck and how it's behaving, you find out that this gentleman isn't really driving it for work. He isn't really driving very fast, even though he said top speed is very important. And then when you observe these human beings, you notice that they're doing very different things. What drives them to own the truck isn't really driving to work, but it's having fun within the private moments of his own when he's up on a cliff somewhere. When we go back to this whole concept of transportation, you would probably notice that infrastructure is the foundation, right? You need to have good railways, you need to have connected cities, but then you have to look at integrating it all the way back. The work we do with many of our customers as well as with some of our partners, we notice that the integration of transportation starts all the way from the infrastructure to the modes of transit. You know, are you going by air? Are you going by Hyperloop? Are you going by rail? To the technologies which go into the vehicles, right? All the way into the augmented experience. I mean, how many of us today would actually like to get dropped in a strange city without access to a good navigation software and a good translation software. 10 years ago, we would have carried big Lonely Planet guidebooks. Would you like to have got dropped without that? No. But this is what we believe is going to be the future of virtually everything. How do you integrate from your heart into your mouth, into the world around you? And it requires a whole different kind of engineering now. And in fact, one of the things which impressed me most about the Hyperloop team was it wasn't just a team of mechanical engineers and software engineers. I like the fact that there were human science graduates in there. I like the fact that there were design graduates in there. And most of all, what I really admire about the team is that in the short time that they have done this project, they've gotten the kind of experience that if you work for a great design firm, you would probably waste 3 promotions and 8 years trying to get. And we're really amazed at the way at which they integrated the project, they work very professionally through it, the number of partnerships they manage, the number of engineers they talk to in different countries. It's been really amazing, and all we want to say is good luck and Godspeed. And
thank you, Manoj. Thank you, Manoj. So, Manoj and Eduard have been talking about building a better and connected world. But sometimes we as humans are limited in doing so because of current infrastructure, already existing infrastructure, and decisions made in the past. But imagine for a moment that's not a problem. Imagine that you can start from scratch, from a blank sheet of paper, just a pile of sand. What would you do? What would you then build and build first? And now comes the scary part of the evening, of the afternoon, because I'm actually curious what you guys think. So, if you would have the option to make an entirely new transportation system, what would you do? What would it contain? Who should I ask? I think I'm not going to pick the team because I know what answer comes out of their mouths. So let's go here. Can I ask you what your name is?
Martijn.
Martijn.
Yes.
What would you build first if you build a new city?
I would at least have something with as little traffic jams as possible.
Little traffic jams. And
Yes.
do you have an idea for that?
I think it's too easy to say Hyperloop now.
Yeah.
So,
That would be a good answer.
yeah, I know. Something where you at least wouldn't have drivers, so you would avoid all the accidents because that would cause all the traffic jams.
Yeah, that's a very good suggestion. Thank you. So driverless systems. I think also the Hyperloop will be driverless, of course, to make sure that we have optimal flow. Okay, who else shall I pick? Okay, I'm gonna ask you. What's your name?
Jarno.
Okay, what's your idea? What shall we build first? What would you build first?
I'd build the houses first. Make sure you have a place for a flying car.
For a flying car.
Aerospace.
That would be nice. Air Express. Okay, thank you. Okay, I'm gonna pick one last person. Okay, hi. Can I ask you what's your name?
Tanja.
Tanya. What would you build first if you could build a new city?
I guess. Yeah, houses. I guess.
Houses.
Yeah.
Otherwise, you wouldn't have anything to go to, of course.
Yeah, exactly.
And if you look at the transportation, what would that look like for you?
Something that goes really fast. I don't know.
Really
Hyperloop,
fast?
maybe.
Okay. And should it be green or should it be fast or should it be convenient? What's your opinion on this? What's most important for you?
Green, I guess.
Green. Okay. Well, then you're on the right spot here at Hyperloop, I think. Thank you guys for your input. Give them a round of applause, please. Okay, so it's great to know you agree with us on this, except for the flying cars. That's a new one for us. But our next speaker, he actually turned this into a job. His name is Mark Bello. He's from Jacobs. And Mark Bello is thinking about building a city from the ground up. So if you have nothing at all, what would you do? Where would you start? And I first met Mark, it was a couple of weeks ago at an event in The Hague. And I didn't know him before, but he was actually speaking about a few students from Delft figuring out the 5th mode of transportation. So I thought, hey, that's us. So then we spoke afterwards, and I really liked what he had to say about, this sort of future vision. So we thought, we didn't even ask him to speak about us at his event, so why don't we invite him here to speak about his vision. So please, a big round of applause for Mark Bello.
Okay, thank you, Timo and Manoush. That was a great speech. It's very hard to beat, of course. So yeah, I'm very excited, in fact, very proud to be here as a Delft alumni during this event, doing a speech on the future of global transport. So I will share some examples, we are working on as a company. A little bit about my history. I've got a 25 years experience in the oil and gas industry. So I'm not a transportation guy at all. I'm really an oil and gas person being around for the company in Europe, Canada, and the States. But found my final destiny earlier this year to become the CEO of a new company in Saudi Arabia, which is a joint venture between Aramco, which is the biggest oil company in the world, and Jacobs, which is since last year the largest engineering company in the world. And what we do in Saudi is building large infrastructure, airports, cities, large entertainment cities, but also hopefully the Hyperloop, which recently has been announced by the Crown Prince, the new Hyperloop between Riyadh and Jeddah, which will reduce the travel time from 10 hours by car through the desert to a little bit over an hour. So that's quite remarkable. And one of the jobs we're doing I would like to share here is, you see it on the picture, it's a so-called King Abdullah Financial District. It is a very large development in the middle of Riyadh. If you look at it, it's almost as big as Lower Manhattan in New York. And when completed, about 50,000 people will live and work there. Visitors will arrive at Riyadh Airport, will hop on a high-tech metro line, high speed, into Financial District, and once arrived, they will be transported to their location by self-driving vehicles, which can be ordered by an app on their phone. And this is happening today in Saudi. This project needs to be completed in 2020, so the game is on. It's already 2018, because the Crown Prince has invited the G20 to host a summit meeting specifically at this location. So it's quite cool. Being an oil and gas guy, being invited for a Hyperloop presentation, when I got the question, I had no clue what a Hyperloop really was. So I went to a couple of colleagues who were really in the building infrastructure business and said, "What is a Hyperloop?" And they said, "Well, we'll tell you. We will come up with a prototype." And they came up with this, sort of a train in a tube, right? And I was particularly impressed by the design of the windows, which are of course extremely handy when you're traveling in a tunnel from Paris to Amsterdam. So quite cool actually. So. But I think I will understand a lot more today when going through the presentation later on. Okay, so what's happening in Saudi? You can actually consider Saudi as the incubator of new technologies around the world. And one of the projects which will be implemented in Saudi Arabia is a new city called NEOM. It's a city of the future. It will be built in the northern part of Saudi Arabia, close to the Jordan and Egyptian border. New technologies will be implemented in this city. It will be carbon neutral, completely solar powered by energy from the sun, which is quite easy in the desert in Saudi. Circular economy, water as an example, potable and drinking water will be subtracted from the sea by the newest technology in desalination. And of course, the future of transportation will be written in this city. Hyperloop, self-driving cars, somebody talked about flying helicopters or drones. Everything will be implemented in this city. This is a 25-year program, right? So we have time to actually do it. But of course, with a very high commitment for the nature and the environment. Because if you look at NEOM today, it will look like this. There's nothing. It is a complete desert, mountains, a beautiful blue sea with coral reefs. And in this environment, this huge city will be built. And it will look like something like this at the end. Sort of Dubai on steroids, if you look at it. Right? It's unbelievable. All right, so a few words on global trends in transportation. We as a company, we see 3 major trends, and I would not be surprised if I explain them to you. One of them is, of course, huge population growth going forward. Right now, we have about 7 billion people on the Earth. In the next couple of decades, it will grow to approximately 9.5 million people. So it's about 80 million people a year we're adding to world population. And of course, all these people would like to travel. And then if you add up the rising middle class in China and India, who also want to travel, following Manus's presentation, you can see that we have a problem, right? And so normal transportation solution will not suffice anymore. So we have to go to something like Hyperloop. The second trend is the digitization of industry and our daily lives. Everybody knows about the Internet of Things, blockchain, artificial intelligence, robotics, you name it, it's all happening as we speak. It's almost like an electrification of our industry. But of course, electrification of industry will require energy, much more energy than we're using today. But at the same time, we have all the climate issues which Eduard talked about. So we need to find a way to solve those problems. And that's really the third trend we're seeing in industry is the energy transition, moving away from fossil fuels to renewable energy going forward. And all these 3 trends are really driving, a big transformation, how we will behave in the future, and how we will live and work, right? So a lot of change is in the air. And then, of course, big data, I would like to talk a little bit about. We as a company are being asked quite frequently from cities to really help them solve their congestion problems, which are only getting worse with population growth. I had the personal experience to be in New York 2 weeks ago and had to travel from downtown Manhattan to Kennedy Airport, which normally should be a half-an-hour drive. It took me 3 hours, to get out of the center onto the airport. Very, very difficult. So it's really a problem. So, in the old way, an engineering company like Jacob would solve the problem is by doing surveys, on the street to really identify people movements where they would go. So sir, where are you going? And then we would, make a list, and it will create a picture of people movements over time. Nowadays, with big data, there's different means in doing it. We're using cell phone data, aggregated anonymous data to track people movements, where they go and when. We're using information from Uber. We're using information from street cameras, and all that together will provide us data to provide proper analytics to solve the problems of these cities. It's a very, very new way of engineering solving problems compared to the old days. All right, so what are some of the solutions we are providing? And you see these developments all over the world. One of them is connected vehicles or connected automated vehicles. You see these projects emerging at the speed of light around the globe, in China, in the Middle East, in America, and in Europe. And these are vehicles, like you can see on the slides, which are connected to the internet. They communicate with the cloud, they communicate with traffic lights, they communicate with people, and in fact are creating a sort of ecosystem, a transportation ecosystem, to bring people from A to B in a very efficient and safe way. It's a big change which is happening all around the globe. So yeah, I'm here today as a proud sponsor of Jacobs, doing this keynote. We have about 75,000 people worldwide who are providing solutions for a connected, sustainable world. I keep silent here because a lot of people think that engineering contractors, that they actually design projects and build them. We see a big change in our industry, from doing projects to providing solutions, which means that the people we need in our company need to be people who are able to look beyond their specific discipline, who need to be able to communicate over cultural boundaries, and need to be able to look at the big picture and not only at a single problem. I think the Hyperloop team is a very good example how that would work, going forward. So I know there's a lot of students here in the room. Maybe this message will help you to to define, what kind of courses you would like to take in order to diversify, your knowledge about certain things, and also to choose what career path you would like to take. A good example of looking beyond your boundaries is a new design trend, which is using biomimicry to design whatever you want to design. And biomimicry is the science to really look at nature and try to use nature solutions into your designs. A good example is the Buddha train in Japan, which was modeled. The nose of the Buddha train of the train in Japan was modeled to the beak of the kingfisher bird in order to reduce resistance, but also to reduce noise levels in tunnels. It's a fantastic design. And I would like to encourage everybody to take a look at internet and go to Janine Benius. She is one of the founders of biomimicry, and watch some of her YouTube videos, her TED Talks, to really get inspired about what nature has to offer. So, in conclusion, we would like to congratulate the Hyperloop team. I cannot see them. I think they're somewhere in the back. Hello. I'm sure that nobody slept last night to get ready for this event. So congratulations with the event. We at Jacobs are on a global hunt for talent, so we are watching you, each of you individually, but soon the world will be watching you in California. Thanks.
Thank you, Mark. I think we just got a job offer, but I'm not sure. That's also, of course, the reason we do such a dream team year. No, sorry, that's all kidding aside. What I hear from the story of Mark is that entrepreneurial spirit is super important when you go about these challenges. And I think it takes some guts and some entrepreneurship to go from a pile of sand towards a new city. And we, within our Delft Hyperloop team, also have this entrepreneurial spirit on a smaller scale. But actually, we have two team members, Dirk and Rico, and they have started their own business during their Hyperloop year. And so, since a few months, they run a successful snack corner at our Hyperloop base. And they provide us with the most delicious cookies and candy and chocolate bars and energy drink to keep us all going. But to reassure all the parents in the room, we also get a weekly fruit box from Vitamine & So. So we get enough vitamins, so don't worry. Okay, so we kept you waiting long enough, and now I think it's time to move on with the pod reveal moment. And to do so, we couldn't think of two better people than Maurits Hoek and Vlad Petrescu. Vlad Petrescu is our chief engineer, and he focuses on delivering the highest possible quality pod. And Maurits, on the other hand, he is our technical manager, and he makes sure that we get it done within these 9 months. And you can imagine that quality and time do not always match, so that's an interesting trade-off for these guys to tackle together. And also in their way of working, there are a little bit of differences, because Maurits is always running around through the office. I think he runs a marathon every day, trying to help as many people as he can at the same time and gets a lot of stuff done. And Vlad, on the other hand, he is a more calm person, and he tries to really focus on specific aspects and really try to seek excellence in these single points. But although these guys are quite different, I think this makes them a really good team. So they'll be the ones to reveal the pod in a moment. But before they do so, a short remark, because before you enter this room, you got a piece of paper, and you can write your name and email address on it, and also your speed estimate of how fast our pod will go in the tube at the competition of SpaceX. So pay very close attention to what these guys are saying, because that enables you to make the best guess possible. When you leave this room, you can hand your card in with your answer, and of course we'll provide the winner with a nice prize. But I will just stop talking now. I think you've been waiting long enough. So I'd like to welcome Maurits and Vlad on stage for the pod reveal. Thank you. So
Wow, that was an amazing Hyperloop future that was described. This is also the first time that I saw these renders and that epic video in the beginning. But how can we Delft Hyperloop start and take that first step towards the future of transportation? Shall I already reveal?
No, not yet, Maurits. Wait for a second. What are we actually doing right now? What are we revealing? Let's take a step back.
Yeah, the step back is a good idea. 3 years ago, Elon Musk revived the Hyperloop idea. And let me introduce you to his playground in California. Near LA, you probably all know, he has his rocket factory, SpaceX. And at the one corner of his facility, he has the first self-landing rocket booster. And at the other side of his SpaceX facility, he has his Tesla design studio. And probably not that far away, he also has parked a private plane, which is not that remarkable because most probably the entire airport is his private airport. And now he took, 3 years ago, he took the first step towards the Hyperloop. And he built 1 kilometer of tube on the main road right in front of his office. But to develop the capsules, the Hyperloop pods, the prototypes that go inside, he announced a competition. He announced a competition for student teams all around the world. And Delft Hyperloop was, 2 years ago, one of these teams. And we showed the world that it's actually possible to build such a prototype. And we showed the world, and we won.
Last year was very amazing. The team won, but now the rules have changed. There is a new competition on the table. And the goal is the top speed. And why is that? As Edard mentioned before, a Hyperloop must be very fast, very reliable, a very safe mode of transportation. But in order to get there, in order to achieve this high goal, we must break it down into smaller steps. So let's first look at the top speed. Let's first look and try to understand why Elon Musk tried to make the goal of this competition to be the top speed. In our opinion, it's because we must understand first how the vehicle behaves at those high speeds. And in order to do that, we must also look at the track that we have available, that he constructed in Los Angeles. Because it's a 1 kilometer long track that has vacuum inside, and that helps the pods to move forward without any air resistance. So while doing that, we're facing multiple challenges. And the first one is the tube itself. We must accelerate and decelerate within 1 kilometer. And all of that in a very harsh environment, something that your car is not really experiencing, so that we need special attention when we're doing that, because we're coming across electrical challenges as well as thermodynamics challenges.
And that challenge, we have to do it in 1 year. We all started with our team the 1st of September. And the 1st of September, we started with a blank sheet. We didn't know where to go. We could decide it for our own. And at the end of the year, in the 22nd of July, we have one chance in which we have to show what we have got, what we have done the entire year. Basically, the entire year is one big countdown to a horizontal rocket launch. And in this launch, we push the limits of what is fundamentally possible. We push the limits of engineering in the vehicle we are about to reveal. We push the limits in our team, and we push the limits of ourselves.
But the good news is, we overcame all these challenges. So, ladies and gentlemen, we present you Atlas, the future of the Hyperloop transportation launching system.
Good afternoon. This is your captain speaking. On behalf of Delft Hyperloop Tubeways, we'd like to welcome you aboard this Hyperloop pod. Today we will loop you from Delft to Paris in just under 30 minutes. Please fasten your seatbelts, as the launcher module beneath your feet will take you to unparalleled speeds. This speed is made possible by an extremely powerful battery connected to a world-class drivetrain system. Don't worry, the suspension system will guarantee a silky smooth ride. The navigation and control unit will monitor the health of the vehicle and its lightweight structure. When we arrive in Paris, the state-of-the-art braking system will comfortably bring the pod to a standstill. We would like to thank our partners, friends and family for making this all possible. Enjoy the ride. We will depart in 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Wow, what an epic moment. Yeah, cool.
Let's talk about the goal of this vehicle. What is its main purpose? So as mentioned before, the tube is 1 kilometer long. And our main goal is very easy. We need to get to that top speed. But in order to get there, we must accelerate very fast, above 1G, and decelerate even faster, 6 times faster than we're accelerating. And we're doing that all within 1 kilometer. So let's imagine we are at the start line. We are at the race. The pumps bring down the air down to 0.1% of the vacuum. It's what we call a medium vacuum. And it's becoming very quiet. The team is outside, behind the monitors, trying to take the telemetry out of the vehicle, trying to understand what happens at those low pressures. And we're receiving data. We're checking the subsystems, we're checking the motor, we're checking the batteries, we're trying to see how they are. So let's have a look inside. Let's take the aeroshell off and dive into the technical subsystems.
We have to be very careful now.
Yeah, here is fine.
Nice.
What you first see here is the battery. Inside this black box, inside this sealed box, we have about 16 of these modules that together have so much energy that can charge all of your phones in this room at the same time. And you might say that, okay, my phone has pretty good capacity, it can stay on for a day or for 2 days, but it's not only about the energy, it's also about the power. Because if I ask right now from that cell from your phone to discharge it in a very few seconds, it cannot do that. But that's what this battery can do. It provides energy and power to accelerate very fast in a very short period of time.
And if you further break down this battery, you actually find out that this battery is composed of 768 small, tiny lithium polymer cells. And the assembly of that battery was a tedious process. Our powertrain engineers assembled the battery cell by cell with small pieces of rubber in between, mechanically. And they also assembled it electrically by the use of laser welding. And together, as Vlad says, this battery forms a huge, dense block of power, and that brings high safety standards. So that's why we monitor of every group of 4 cells, the voltage, the current, the temperature, in order to make sure that it stays healthy, the battery. And George made it even possible to real-time check your status of the battery on your phone. So now, we have all the power packed in this battery, but how to convert that energy into speed, because that's where it's all about. For that, we need a sort of transmission system. And the transmission system is crucial for the acceleration profile we will get in the end. And that's why some decisions made in the complete beginning of the year were crucial for a final result. So decisions between option A and B. And right now, at the end of the year, during these weeks, we test that transmission system and we evaluate how good our choices in the beginning were. And that comes with setbacks. We blew a tire. We had even a small explosion. But that's also good news. It means that we are by solving these solutions, by solving these challenges, it means that we grow as a team, that we become more flexible, and that we are able to fix problems. And in the end, we also start pushing the limits of engineering, and we get until the top speed. And how do we get to that top speed?
Well, it's actually very interesting to follow the power, how it's being converted from the energy source. And then it goes into the motor controller, which sends pulses and signals to the motor that basically converts this power into the torque. And this torque, we want it to end up in the wheel. But in order to get there, we're using a gear transmission, a gear ratio 1:1, in order to transfer all this torque to the wheel. But as you can imagine, when you accelerate very fast with your car, when you start accelerating very fast, sometimes your tire is slipping. And that's why we want to prevent, because we want to accelerate extremely fast. And that's why we have a clamping system, which provides pressure on the tire in order to have enough grip to accelerate so fast.
And we accelerate until top speed. But what happens at top speed? 150 years ago, people thought that if you would enter a train, and right then the newest mode of transportation, and that train would go faster than 30 kilometers an hour, that weird things would happen to your health, that your brain would start to boil. But of course, right now we know that's not going to happen. But what will happen to our vehicle at those crazy speeds?
In order to understand what happens with the vehicle, we must first look at the track. Because this track is built out of multiple joint segments, which have some imperfections. And they are caused either by misalignments due to manufacturing errors, or due to heat expansion of the tube, or due to earthquakes. But nonetheless, they will always be there. And these few millimeters, they end up being converted into huge forces and huge vibrations, which will go eventually in the structure. And that's what we don't want to have. We want to have a very lightweight structure. So that's why we have a suspension mechanism on board. And every wheel is suspended so that we mitigate all these forces and we damp them in order to have a very, very lightweight structure.
And that's also where the importance of production comes in. So most of the parts, we machined them ourselves at our production facility. And that happens most of the times in the night. So for example, a few parts here were actually finished this night. Or this morning, I don't know how that works. From these bars and blocks of material, we milled, lathed, water cut, laser cut, and CNC'd material away and away and away until we ended up with aluminum brackets like this. And we actually have, including spares, 504 aluminum parts like this. And probably that amounts even higher because sometimes Vlad says, we have to make this part all over again because it's not accurate until the last micrometer. And then we start again, or the production team starts again. But they do a great job in making those suspension parts.
But it's important to realize that we need to have the right balance between having a part in time and having it very accurately designed and very, very optimized, very lightweight, because that's the chassis is the best example. How much do you think our chassis weighs? You might think it's something like 20, 30% of the total vehicle's weight. Well, it's actually 8%. It's only 11 kilograms. And this chassis, there was so much engineering work behind it in order to optimize the shape and come up with this efficient stacking of the plies. Because carbon fiber is very well, behaves very well in tension, but when you stack it correctly, it can handle also bending very well and other low cases.
Yeah, and the chassis department was always first in our year. So they were the first to start cooking at our office. And they were the first to order a huge amount of materials and parts from our widespread supply chain of partners. And they were the first to move to Flevoland and to start production right there. And imagine how that production, how heavy and nerve-wracking that is. Imagine that for 2 weeks you're manufacturing the chassis, ply by ply. Plies like this, sometimes it's a little bit bigger. It's a pre-preg ply, so the resin is already in here. So that's also why I shouldn't touch it too much. They're assembling it ply by ply. And then there's one moment at which everything can go wrong, and that they have to start all over again. And of course, that moment happened. They were the first to experience that moment, but they were also the first to solve that challenge. And they were the first to actually finish their subsystem, the chassis. And probably they are also the first department to have actually a subsystem finished right now. But that's important because as soon as the chassis came out of the mold, the chassis started acting like a magnet, and it started attracting all other subsystems and parts, and assembly began. And so this is the carbon production, and here the assembly begins. So, this process went very rapidly. As soon as the chassis was there, every part starts stacking on the pod.
And all these subsystems, especially chassis and the suspension, they make sure that the vehicle stays together throughout the entire race, but especially at the top speed. So we are now at the top speed and we need to make a decision. And the best subsystem to make that decision, when to brake, is the electronics, the navigation and control subsystem. Because no one in this room can react so fast as this subsystem. A split of a second too early, and we're missing our top speed. A split of a second too late, and we're crashing into the end of the tube.
And at that moment, the decision for braking is made. A lot of things happen at the same time. So a signal from the brain, the navigation and control computer, goes to the solenoid valves in the braking, and they release a huge amount of pressure from these tiny little tanks. And the air flows through the pneumatic system to the calipers. And the calipers press in no time, in 0.3 seconds, the pads on the track. And by mechanical braking, our pod comes to a standstill in only a few seconds. And the good thing is, and a very important thing as well, is that this braking system, also in the future, should be fail-safe. So that's why it still works if there's a power outage. And what's really nice and what's the good thing is, we have this system twice.
The design is very nice and very reliable, but we need to have it working. We need to test it. And that's why we did this small test setup. And we tried to simulate a disk spinning at our top speed. We wanted to brake in real time and see how much time it takes to basically bring this disk to zero. Let's see what happened. Maybe you think that's slow, but in parallel with this disk, there is an even bigger disk attached to it, which simulates the entire inertia of the vehicle. So this is basically a real-time braking from roughly our top speed to zero. But this wasn't sufficient for us. We wanted to find the limits of our braking system, so we made another test. We put this time a bit more pressure. Same speed. Thanks to this wonderful subsystem, which must be very safe, we are now to our finish line. We are back to standstill. And we must look back and see if we achieved our goal. Try to understand what happens with what happened with the vehicle throughout the entire run, what happened at that top speed. Let's start collecting the telemetry. And to conclude, all these subsystems make sure that our vehicle is a very highly performant machine. And the quality that was invested in these subsystems made sure that the power is maximized while keeping the weight very low, and thus maximizing the power to weight ratio, which brings us to the top speed.
And not only do we need high performance, but of course we also need it to work at the right moment in time. And we need it to perform that performance. And that's basically why we tested our vehicle. We tested literally everything. So we tested our vehicle for vacuum at the European Space Agency already a month ago. And we built a small piece of track right here in our office. And on top of that, Vlad calls it a small test setup. I call it a large test setup. Somewhere in a bunker, because it's quite dangerous with all this energy in the wheels. We built a test setup with wheels that simulate the speed of the pod, but also simulate the inertia, the mass of the pod. And this made it possible to test our braking system and our acceleration system, our transmission system at top speed.
And by making sure that we met all these accuracies, we aligned the wheels perfectly, we achieved the right quality for getting to that top speed. But not only, we also achieved very high reliability by testing again and again our vehicle every single time. And not only our vehicle must be a very performant machine, but also our team. Similar to Formula One pit stop, our team must be able, at every single point in time at the competition when we're going to get there, they must be able to fix the pod and make it prepared for that final run of glory at the SpaceX competition.
Yeah, and together with our team and the vehicle we just unveiled, we truly think that we can push those limits of engineering as far as possible and take that next step towards the future of transportation, towards the Hyperloop. Thank you.
And so for the last year, we've been working in a really awesome team to make all this happen. It's really an honor to be able to work on such cutting-edge technology, such a revolutionary project. But really, it's even a much bigger honor to be able to work in such a team. We often feel, however, that people don't quite have the right idea of what it's like to be of the Delft Hyperloop team. Probably because of our well-polished PR image that our PR department works so hard on. But we tend to think people forget that we're students going through a learning process. I mean, we're driven, and we work hard, but even like the best minds put together, we still make mistakes, and we still go through hardships. So I have a hobby, and I like taking pictures. And there really is no way of properly explaining what the full Delft Hyperloop experience is like, but I will try, as seen through my eyes. So, Delft Hyperloop started over a year ago with actually just the two of us, Maurits and I, right after the first competition. And this is something you'll see recurring quite a lot. It's Maurits reading or working, and in this case, behind a computer or two computers in the train. Soon afterwards, we were joined by 4 recruits, where we occupied a space at the Dream Hall in order to think of our top-level concept, and try and think about how we're going to start the year. Now, right after that, you see us finally here, one of our first pictures in our office. Now, we didn't actually know if we were going to have an office or even a competition until really, really late, just a few weeks before we started. So we had 37 team members already, and we had a team ready to start, but we didn't even know if it had a location yet. But here you can see us finally very happy with our location. And so then it became time to start, and it became time to get to know one another before we could really start. And so we did this in the east of Holland in our first team weekend. I don't know if you watched our first presentation, but ironically, we did this with canoeing, with canoes. And so then it was time for us to really start. A really exciting time for us. A new old office, new team members, and new ideas that we were all trying to bring together and put into our preliminary design. We were starting to get to know one another, and we were starting to become friends. And we were starting to become a team, united. And so then came the night of our first big deadline, the preliminary design package. And I think this picture really sums up that deadline really well. Here you see, if you look closely at Gigi and Bart's face, you can really see the despair and hopelessness. As this picture was taken at about 4 a.m., and they knew they still had to work. In fact, the whole team still had to work all night long, and we did. We spent the whole night working on this. We did an all-nighter in the end. But at this point, you can see them sort of realizing this. And you can also see, again, the despair and hopelessness in Gigi's face, but also how different people deal with stress in different ways. And so we started making it a habit of working long nights. And the Delft Hyperloop offices would be occupied later and later in the evening. And then winter came, which for us was quite cold because the heating at Delft Hyperloop works sometimes. And so you could see that we sometimes had to work in near zero temperatures, and how we would try to deal with these situations with creative solutions. Sometimes working in sleeping bags or in winter coats next to heaters. And I think this picture basically sums up what a Delft Hyperloop Christmas looks like. I think it speaks for itself. I don't think I have to say anything anymore. And then so finally, after our detailed design phase, it was time for a well-deserved and far too short break. And we had our second team weekend in Texel. We met some baby sheep. We had some fun. We even went for a nice icy cold swim in the ocean. But before we knew it, we were back at it, and we were back into our production phase. And so we started producing pictures of Flevoland. And I think this picture really sums up really well what a really big part of this year was for many team members. I was only able to capture a few of these moments, and this is a moment where things go wrong. Now, in this picture, the vacuum infusion is actually going wrong, and the resin isn't properly spreading through the tubes. And what we have to do here is actually cut into the tubes, basically open heart surgery, stick them back together in order to get the resin to flow through the tubes again, and like blood through the carbon in order for it to work. Now, if this goes wrong, they have to basically redo a whole week of work. And you can see that in their expressions. But luckily, they stayed cool, like we usually do, and we tried to solve the situation. And we did. This is a happy ending. But I can tell you that there were more than enough times that we had a situation like this, and that it didn't go well, and that it cost us days of work that we had to redo. And so slowly, things started coming back to Delft in order to be finalized and brought together at our office. And it's not always easy to work in full carbon suits in 30-degree heat, but we try and make the most out of it, like Adriaan, when we can. And so this is something you'll see reoccurring quite often in our team. We try to make the most out of our situation, and we try to have fun when we can, and we try to enjoy ourselves whenever possible. Another popular way we like to relieve stress in our team is with short walks around our office. We have 5-minute walks or 10-minute walks whenever we can, talk about our problems, our stress, and then get back to work. But we also get help from multiple coaches. And these help us and teach us how to work with one another and get the most out of each other while still remaining respectful to one another. And this is really helpful for us. And so, as a result, we started to help one another wherever we can. But slowly and finally, our deadlines started coming towards us. This day, the pod reveal, the day that everything needs to be finished. And as this happened, working hours became more intense, problems became even more stressful, and faces became more tired. But despite this, and despite some of the marathons people have been pulling, like the shifts the production team has been working throughout day and night in order to get these parts here on stage on time, but also things like the station that we've been working on to get them on time, we try to remain positive and try to keep smiling and try to keep enjoying ourselves in order to reach our goal. And so this, of course, is another really big moment for us, the pod reveal. And if you don't mind, I'd actually like to capture this moment as well. So if I could have the lights please turned on. I'm gonna grab my camera right here. Oh. As you guys can all just smile and put your arms in the air. Yeah. That's really great. 1 second. Gotta get, okay. One more. Okay. And one with funny faces. Okay, great. So that's great. And now, all of you are also part of our story. And so, we have done all of this, not only for the challenge or for the fun, but also because we really believe that a change is needed in this sector in order to make for us a brighter future. And that is why, aside from the launcher, our team has actually been working on something else. Something very special. So, aside from building the launcher, we have actually developed and created a passenger module. Now, we have done this because at Delft Hyperloop, we know that new technologies can be overwhelming. But we want to show you that there's nothing overwhelming about Hyperloop as long as you make the right choices. So on the passenger side, there's two main challenges. First of all, you can't have windows. Second of all, your pod needs to be relatively quite smaller compared to your tube, as you need to allow for air to pass between your tube and your pod. You might think, air? Well, at these speeds, even the tiny amount of air in the tube will actually influence you. So you could make a really big tube for a big pod, but that's really expensive. So are there ways of making a small space comfortable? The answer is yes. Do you think private jets are comfortable? Well, our pod, or the interior of our pod, at full scale, of course, because it's a half-scale pod, was actually bigger than that of a private jet. But there are more ways of creating comfort. For one, we have optimized our seating arrangement in order to create the most social interactions. Basically, a very scientific way of saying we have our seats, people talk more. And we actually have ergonomic chairs in our design that are optimized for the best position for both relaxing and for work. The screens in our vehicle, if you go through different time zones, will actually adjust in order to not affect your biological clock. And in our vehicle, we also have displays which show you things like time, speed, location, and weather, and time of arrival. All things that let you know that everything is under control. All you have to do is sit back and relax. So on the outside, we have a water drop form, which is both optimal for aerodynamics and for pressure retainment. In the end, it's most important to keep you happy, the client, because in the end, it's you that will decide if Hyperloop is successful. So that's why it's the most important to make sure that you're happy. And then the passenger module will slide underneath, connect the launcher slide underneath, connect to the passenger module, and take it away, creating a modular, fit-for-purpose design. To conclude, with the launcher, we are pushing the limits of technology at the competition. With the passenger module, we are working on the future of Hyperloop. And together, we work and make a tangible step towards the future, towards reaching the Paris Accord agreements. So if you believe, just like us, that we require a change, because we cannot do this by ourselves, please stand up and join us in our mission of making that change. Thank you so much.